this. Okay. Welcome to class. Excuse me. We are today going to be going over energy again. We're just going to review what we learned last week, as well as proceed with this week with learning alternative forms of energy. So things that are hopefully cleaner and last a little bit longer. So that's the plan for today, is to discuss those things. And so I have a couple questions in here in the on the slide for you, right? So we talked about energy last week, and you guys hopefully learned about different kinds of energy. And so we're going to review what some of that energy might be, especially if you can answer this question here. So, what kinds of energy do you interact with on a daily basis? So to get your mind thinking about that, what are all the things you've done so far today, and what kind of energy did they require? Right. So a lot of you are coming from class already for the day. You guys may have already attending your writing class today. Some of you may be just waking up, but whatever the situation is, what kinds of energy have you used today? All right. So we're going to discuss that. So go ahead. And let me know what kinds of energy you guys have used today on this Friday the 13th. So no one has used any energy today?
Just to write. Anyway, we've used at least with the food, the
Okay.
energy we've got from the food,
Yeah, very good.
and
What kind of energy is that?
Hmm, wait, oh,
What kind of energy is that?
I
Yeah, so I see that in the chat I have solar energy was used. Good. Yeah, solar energy. If you have solar panels, that's how you're getting your electricity. So you've used solar panels today. If you're on your computer, you're
Gas.
using some kind of energy. You have to
I
be.
use gas, I use internet, and I use the light.
Okay, so if you use gas, what kind of energy is that? What kind of energy is gas energy?
Oh,
What do we call that? It begins with the T. It begins with the T.
a gas. Uh,
mm-mm.
What kind
is
of
is the
energy
gas
is
not fuel?
gas energy? It's thermal energy is gas energy.
Okay.
Thermal energy, right? Because
Oh,
that's how we're using geothermal energy, to be more specific, right? We're getting it from the earth. That's geothermal energy. So we talked about solar energy already. um, Electricity is a form of light or heat energy. Chemical energy, if we've eaten food today
that was what I
and
was
we're
thinking.
moving, even if you're not,
Elec-
if you haven't eaten, you're using chemical energy or stores of chemical energy, right? When you move your body, which I'm hoping you've done today, in order to get onto your computer, you have had to move your body. You're using mechanical energy. Okay. All right. So all of that movement, all of those different things, those are some of the different kinds of energy we've kind of talked about. Remember that all of the energy um, that we have on the earth all comes from a singular source, right?
Mm,
That source
mm,
is the
the sun.
sun, right? Without the sun, we can't have any of the other kinds of energy, because none of the energy that we have on earth is created, right? It is all transferred from one kind of energy to another. And at one point, all of it had to be energy from the sun. So solar energy, light energy, heat energy, it all came from the sun and was transferred into different things. Okay. So we transfer energy, we don't create energy. Right? We just transfer it. Okay. All right, so today we're going to talk about the air as well as alternative kinds of energy. So I'm going to go into Schoology and pull up the discussion post, which you guys can enter your responses in there. I actually see that somebody has already put in their responses already. Very good. That's great. If you can't access Schoology, you can put them in the chat, but I'm going to bring up the response, the discussion post first. Let me go ahead and grab that.
What's the energy for technology, Mr. G? Using the internet?
So if you're using electricity, right? So the internet doesn't require energy, but electricity does, right? And so that's a combination of light and heat energy that we transform into electricity. Okay, so I'm in your science class here on Schoology, and I am going to be going into week number 9. Week number 9 is air and alternative energy. It has today's date on it, November 13th. That's how you know. It is Friday the 13th, just so you all are aware. All right, and so what we're going to look at is the what is air pollution discussion post that I have here. So in this discussion post, I have what is air pollution, right? And so that's the question I want to ask you guys. What is air pollution? So you can tell me what it is. You can use whatever knowledge you have already. You don't have to do any research. But what is air pollution? Tell me what that is. You can put it in the chat or put it on the post. Of course, I'm sorry, I need to go back here into your course and actually pull it up because you can't see it. Okay. So here's your Science 3 course. I'm going to go into week 9, air and alternative energy. And so the question I'm asking you is right here, what is air pollution? And what pollutes the air in DC? So tell me, what is air pollution?
Air pollution is the releasing of harmful gases like carbon dioxide into the air.
Okay. All right, carbon dioxide in the air is air pollution. Okay, what else is air pollution? Anything else? Just carbon dioxide? But is carbon dioxide a harmful gas? I mean, plants need it, so is it harmful? What makes it harmful?
When it's too much.
What makes
when
it
it's
pollution?
Okay. When it's too much, and
Okay.
when the plants are cutting down and has no access of absorbing it, it becomes harmful.
Okay. So too much carbon dioxide is air pollution. Okay. Anything else? Is there anything else that is an example of air pollution?
From the car, the cars brought. I think the car, same thing. It brings out carbon dioxide, right?
So the exhaust from cars, right? Exhaust from cars cause air pollution in DC. Anything else that causes air pollution in DC? Let's see.
Factories.
Factories, okay. Factories cause air pollution in DC. Very good.
Tobacco.
Oh, good. All right. We got all that smoking.
Yep.
People do love to smoke in DC. It's true. Okay, smoking definitely causes air pollution. Absolutely. Are there any other things that cause air pollution that we can think of? Let's see. We did cars, factories. this probably isn't a big deal in DC because we don't have the space for this, but definitely in other places, something that will cause air pollution is farming, right? And not farming of crops, but farming of animals, right? Because when you have a lot of animals collected in one area, they're going to produce gas, right?
Okay.
Right? They're going to produce, because what do animals do all day but eat, and sleep? They poop and they fart.
Yeah.
And that actually, so a lot of animals together will actually pollute the air, right? Because they put a lot of that back into the air. So it's not going to be a problem here in DC, right? Because we don't have the space for people to be raising animals like that. But that's something that does cause air pollution in other places.
And the fertilizer they use for the crops, like the chemical they use for the crop to grow the crops.
Exactly, true.
So what was the question? What is air pollution? Oh, what is air pollution?
Yeah, what is air pollution and what pollutes the air in DC? Yeah.
Oh, okay.
What pollutes the air in DC?
So Mr. Michael, most of us is inside the house. We're much safer now, right?
I'm sorry, I didn't hear you.
I'm just kidding. I'm saying like when most of us is in the house now, we're much safer than being on the outside. Pollution.
From the air pollution, absolutely, right? Yeah, I mean, you're definitely at a lower risk inside to air pollution than you are outside. That's very true, right? But also people can be self-polluting their own air if they're smoking indoors and things like that, right? So you just have to be a little bit aware of that as well. As long as you're not smoking yourself to death in your own house with closed windows, then yes,
I smoke. I don't drink.
You should.
And then what of cutting down the trees? Does it really pollute the air, or it just?
Oh, absolutely. Like what? When we cut down trees, and that's something that we do a lot in DC, right? So something that's going to cause air pollution would be deforestation or like removal of trees for building, right? That's definitely something that's going to cause air pollution. Why? Why do you think it would cause air pollution? What's happening in that case? Not even just the process, which can be harmful, but what else is happening? What happens if I remove a tree? What am I removing?
Because it's going to. It helps to absorb the carbon dioxide to produce oxygen. So when you cut down all the trees, it will be difficult for it to suck out the carbon dioxide. So it will be
Yep. Absolutely. Yeah. It's a natural filter essentially. Good. That's good, right? So the idea here is that without a tree, without that one less tree, right? That one less tree means less carbon being absorbed out of my air. Exactly. So it's just it makes the air dirtier when I have less trees around, right? And we do that a lot in DC, right? Let's say like move trees out of the way, move plants out of the way to make space for more high rises, because that's what we need, right? We need more high rises that people can afford in this city right now. More $1 million condos. There's not enough. We need more. Okay, good. Yeah, so that's very good. You guys, so I think you guys definitely tackled that idea pretty well, right? Like air pollution is essentially that, right? We're going to go a little bit deeper and talk about what actually makes air polluted and how we measure that. There's definitely a system in place to do that. So we're going to definitely discuss that a little bit more. All right, so that is your first introduction into what air pollution is. Before I get any further, I just want to highlight something really quick. So in your course, at the very top of your course, the first item that I have in the materials now is a link to the DC Environmental Film Festival. So the film festival begins today and goes through Sunday. So it's not a lot of time, but right now there's a bunch of environmental films going on. And the films they're not all free, but they have some that are free. I'll click on the link and open it up so that we can see. So on this link here, you can scroll down and you will see different categories. You want to keep scrolling until you see the free to view. But there are different films about different topics and ideas related to conservation and the environment. And it's just a good way for you guys to get your own sort of outside knowledge about things. This is just if you're interested, right? This is not a requirement. This is not an assignment. This is not something you have to do at all. But if you have any interest, or maybe you're just sitting around this weekend bored and want to watch a movie, and maybe you learn a little something, right? At the same time. But there's a film called Water is Life that teaches you about the importance of water in 2 different places, in India and in the American Southwest. And then there's other movies as well that are, or other films, I should say, that are free to watch. So that's just a link that's on your course if you want to follow that, just so you know that there's something else going on there. All right, so I'm going to go back to our course and back to this week. Again, we're in week 9. All right, and we are going to learn about the alternate forms of energy. All right, so we're going to learn about we have some vocabulary here. This link is available to you guys. I'm going to pull it up right now so that we can look at some of these words. There are 11 terms, I think, or so, 11 or 12 terms that we're going to learn about here that we just need to make sure we understand a little bit before we get into some of the reading that we need to do. All right, so these are units that convert sunlight directly into electricity. What would that be? Is that solar cell, solar energy, tidal wave, or windmill?
What did you say? Units.
What are these?
Okay, I think it's solar cell.
What?
Yeah, so these are what in this image what we see are solar cells, right? So these are the units that convert sunlight directly into electricity. They are known as solar cells. Okay. What about this? An area of reduced thickness in the Earth's mantle that allows heat from the interior to reach the outer crust. Volcanoes, vents, and geysers are examples. Is that a sun, a hotspot, solar energy, or hydroelectric?
Solar energy.
No, I think it's
so solar energy has to be created by the sun, right? An area of reduced thickness in the Earth's mantle that allows heat from the interior
I think
to reach
it's
the outer crust. So
the
it's
hot
not the sun.
Hotspot, yeah.
Hotspot. Yeah. All right, what is this? This apparatus is used to capture wind power and turn it into electrical
windmill.
It's a windmill, right?
Yeah.
Good. This is the most renewable energy source. It provides Earth with 35,000 times more energy than human activity uses altogether.
What is the?
This is the
most renewable energy source. So solar cell, efficient energy, hydroelectric, or solar energy.
Solar system, solar energy.
Yeah, so solar energy is the most renewable energy source. What does the word renewable mean?
Renewable, that is, you can renew it. It can
like recharging.
Renew, yeah.
It can recharge it, it can come back, right?
Yeah.
Renewable
you
means
can
it can
keep
come
using
back.
it.
Yeah. Okay. All right, so this form of energy.
What was what again, Mr. G?
I didn't hear you. What was it?
What's the answer for that one again?
It was solar energy. Solar energy is the most renewable energy on Earth. Yeah. Okay, so this form of energy is generated by the effect of gravity between the Earth and the moon. Ooh. Is it tidal wave, solar cells, geothermal energy, or hydroelectric?
The form of
energy is generated by the
tidal wave.
Tidal wave. Very good.
Okay.
So tides are what happens when we have the Earth and the moon create tides, like the ocean tides going in and out. Low tide, high tide, that's created by the moon. So yes. Okay, this describes the resources that produce energy effectively with a minimum of waste, expense, or necessary effort. Is that efficient energy, geothermal energy, hydroelectric, or solar energy? This describes resources that produce energy effectively with a
Hydro-
minimum of waste.
Effective
expense.
energy.
Hydroelectric.
Hence energy.
So it's efficient energy, right?
Ah,
So
Naturalistic,
whatever energy
right?
that I can produce the most effectively without any waste or expense is efficient energy, right? And we've used the word efficient before when we've talked about cars, right? We need cars to be fuel efficient. When a car is fuel efficient, that means it's a kind of car that can use the least amount of fuel, therefore costing you the least amount of money to get from point A to point B, right? So when we talk about efficiency, we also talk about how much energy is being used by that object, right? So that's efficient energy. One of the things that is the least efficient on Earth, right, as far as energy use and waste, is the human body, right? The human body is one of the least efficient machines on the planet because we require so much energy, right, to do very little work. Right? When we think about it, we have to consume a lot, and then anything we do, we're like, oh, I'm so tired, right? So we are actually the least efficient machines on Earth, and the reason that is because we have to do so much processing that we don't even think about, right? Even as you're sitting here in class, right, and you're not doing a whole lot, you're listening to me talk. Even that requires so much energy. Your body is doing a lot just to keep you awake and alert, right? So your body is actually doing a lot of work for a very minimal effort. So it's not a very efficient machine. Okay, so this is the energy obtained from Earth's internal heat and can be used to generate steam to run a steam turbine. Is that solar energy, efficient energy, hydroelectric, or geothermal energy?
Hydroelectric.
This is energy obtained from Earth's internal heat and can be used to generate steam to run a steam turbine.
I think it's somehow maybe geothermal energy.
Okay, it's definitely not solar. Solar is the one that comes directly from the sun. We already used that one. It's not efficient energy, so it's either hydroelectric or geothermal. And when we're talking about internal heat, we're talking geothermal. All right, so those are some of the terms. You guys can practice with this whenever you want. It's a good little game. If you want to switch the game, you just click change a study mode and you can switch from learning to matching. And so in the matching, right, it's just like the matching card game. You have the terms and then you have the definitions and you have to match them up. So the most renewable energy would be solar energy. And you just keep matching. The goal is to do it faster and faster. That way you know you're learning all the terms. But you can choose the different ways you would like to study. You can also just choose flashcard mode, where everything just comes up as a flashcard. And so this is the definition. When you click, you can see what the term is. All right, so the most renewable, and I'll zoom in because it's a little small. So the most renewable energy source, it provides Earth with 35,000 more times energy than human activity uses altogether. And it's solar energy. And you click through each term that way. So it's a good way for you to practice the different words and the terms, okay? So once you've done that and you've learned enough, the goal will be for you to take practice number 2, which is the assessment, right? This assessment is of the terms, and the goal is to match all the terms together. And you can do this up to 2 times to try to get the highest score you can as you're matching the terms. So you practice, and then you do the matching so you can learn your terms, okay?
Mm-hmm.
All right.
Okay.
But yeah, so that's just a little way for you guys to learn something new and something and take away something from today. All right, so the last thing I'm going to do with you guys live is talk about the atmosphere. When I say atmosphere, what am I talking about? When I say this word atmosphere?
Atmosphere is the.
What does that sound like to you?
Surrounding.
Yeah, it's the.
Okay, the clouds. Okay.
The gases.
Uh-huh.
Yeah. I know the word, but I'm trying to look for the words to get it.
No, it's okay. It's all good. Yeah. So So atmosphere is a really deep term, right? Or a large term, but it simply describes the air around us, right? Or that's what the atmosphere is in general. So when I say atmosphere, can we talk about just who's around me right now, right? That's the atmosphere that they're creating, right? When I say atmosphere, I'm talking about the earth, I'm talking about the entire thing, right, that encompasses our world and kind of keeps it together. All of the gases, the airs, the weather, the clouds, everything is our atmosphere, the Earth's atmosphere, right? That allows it to be a self-contained planet, right? That is the atmosphere. So I'm going to pull up here what is the layers of the atmosphere. And we're going to take a look at this PDF just for some reference. So the atmosphere is actually made up of many different layers. Okay? We have a troposphere, which is the part closest to the Earth. Then we have a stratosphere. Above that is the mesosphere. And even above that is the thermosphere, right? So that our atmosphere is not just kind of one layer and one thing. There are different layers to it. Okay. When you're in a plane, right, you have to go up through the troposphere and hopefully over into the stratosphere. And why do planes fly in the stratosphere? What's missing from the stratosphere that is present in the troposphere? Clouds, right? In the tropospheres where you have the clouds and therefore you have weather, right? Planes don't want to fly through weather, so they fly above the clouds in the stratosphere, right? Sometimes they are not going to be flying that high because they're not going that long of a distance, right? But the goal is always to get into the stratosphere so that they're smooth sailing, they say, right? And you don't have to deal with turbulence, right? But in the troposphere, you're going to have more turbulence because you have more clouds, you have more interactions with the wind, right? In the stratosphere, there's also less wind to deal with, right? As you get higher and higher, you actually have less wind and wind resistance to kind of deal with, all right? So those are our layers of our atmosphere. Let me just grab something and make sure that we're talking about all the things I want to talk about here in the atmosphere. There's one more thing I need to mention. All right. So in general, just so you know, the Earth's atmosphere is a mixture of gases, right, that surround the planet. It provides us, of course, with what we need to breathe, right? But the atmosphere also helps us in different ways, right? It helps us because without the atmosphere, we would have direct access to the sun and its rays, right? So without the atmosphere, we would be getting burned up by the sun because the atmosphere helps to keep us from the most harmful radiation that comes from the sun, okay? Our atmosphere is also what allows the Earth to stay relatively warm, right? In general, because we have energy coming from the sun and because we have the atmosphere actually traps that warmth in and allows us to stay warm, right? For several hours, for several months as well. We're talking about summertime, but because of that sun, we're allowed to, and our atmosphere trapping that energy and just not letting that energy escape, we're able to stay warmer, okay? So that's why some of the reasons that we need the atmosphere. Does anybody know any of the gases that are included in Earth's atmosphere? What are some of the gases that we are breathing in every day?
Oxygen.
Oxygen, okay, good.
There's carbon dioxide, I think.
Carbon dioxide, of course. What else? Most of our air, though, is not oxygen and not carbon dioxide. Does anybody know what gas actually makes up most of the air in the Earth's atmosphere?
Is it hydrogen?
Which one is it? What gas?
Hydrogen, no.
Nitrogen.
Which one?
Nitrogen.
Nitrogen, that is correct. Yep, nitrogen makes up 78% of the Earth's atmosphere. Okay, 78% is actually nitrogen. All right. right? The atmosphere also includes water vapor, right? Because of our oceans, right? Our oceans are constantly evaporating or giving off a little bit of water that turns into water vapor, right? And of course, our atmosphere also includes some of the dust particles that are flying around from the ground, from the dirt, from other things. They're little things that float in the air. It could be smoke, it could be volcanic ash, it could be dust, it could be pollen from trees and plants, right? It could be salt from the ocean. There's just a lot of things also just hanging out in our atmosphere as well that's not just gas, okay? Right, anything else? Does anybody know what that effect is called? That effect that allows us to stay warm because of our atmosphere? It's named after a building, but it's called
greenhouse.
Yeah, so it's the greenhouse effect, right?
Effect,
yeah. The greenhouse effect allows us to stay warm. So people, when you talk about climate change, people will talk about the greenhouse effect a lot as sort of like this bad thing. And the only reason it gets this bad name is because right now, the greenhouse effect is actually what's causing the earth to become too warm, right? But it's becoming too warm because of all the greenhouse gas, too many greenhouse gases that are in our atmosphere. But without the greenhouse effect, we'd be freezing cold or we probably would have died already, right? So we need those greenhouse gases, we need the greenhouse effect, but too much of these greenhouse gases, carbon dioxide, methane, nitrous oxide, is what causes the climate to change and stay too warm, all right? But that's what we're talking about here when we're talking about these, those gases, again, just in case anybody was trying to take notes, but so those gases that are not good for us and too high of a number are carbon dioxide, right? Which is what we release and what all animals release, but what plants absorb and take in, right? That's carbon dioxide. Methane, right? Methane is the gas that is produced when things decompose, right? So when things die and return to the earth, methane is released. So plants that die, humans that die, animals that die, right? It's also a gas that is produced a lot in landfills. And of course, in agriculture, again, this is the gas that I mentioned when I was talking about the raising of animals, right? Animals also produce a lot of methane because of all their poops and farts, right? So methane is a greenhouse gas. And believe it or not, water vapor is also a greenhouse gas, because if we have too much carbon dioxide and too much water vapor, that creates more clouds. More clouds create more storms creates more precipitation. All of these things are in a loop, right? And they work together. So water vapor is actually another greenhouse gas that we have that affects our life. And then a couple others that we don't have to worry about as much, but are also contributors to greenhouse gas, is something that we find a lot in aerosols or things that come out of spray cans, right? So these things are usually things like hairspray, right? Which people don't use as much anymore, but there were generations and generations of women that would hold their hair together with whole cans of hairspray. And this hairspray would produce chemicals known as chlorofluorocarbons, or CFCs. And those things were very harmful to the atmosphere, right? Because it destroyed the ozone layer, right? That's the layer that we're looking at here, sort of towards the bottom. Let me move this down again. So this layer here, the ozone layer, which is a layer that kind of helps protect us from some of the extremes of the sun. And the ozone layer would get broken down by things like CFCs, like those things that were in the hairspray. And then the last one is nitrous oxide, which is produced when in farming. when we mess with the soil and we use fertilizers, nitrous oxide is an offshoot, and nitrous oxide is actually something that can end up in the atmosphere and actually be very harmful to it. Nitrous oxide is also the gas that they give you if you don't like injections at the dentist, and so they give you the gas instead. The gas is called nitrous oxide. It's the same gas. It knocks you out instead of using a needle. So yeah, so that's our atmosphere and how our atmosphere works. All right. Yeah. So now you know a little bit more about that idea. So when we're talking about air, all right, the air is actually much more complicated than just oxygen, right? There's a lot going on there. There are many, many layers to it, but it's a kind of it's a very important part of the world that we live in, right? We need the air to breathe. We produce air. All of this thing has a little cycle going on with it, all right? So with that, let's go back to our folder and review. Do make sure that you put in a comment here in the discussion post, about what is air pollution. We already talked about it, but I also want to make sure you guys put your comment in if you haven't already. I know a couple of you already have, so thank you. Again, practices 1 and 2 are related. Practice 1 doesn't have anything you actually have to submit. It'll show up like you have to submit something, but it's all about practicing right there on the page, the vocabulary, right? So go ahead and just practice the vocabulary however you want to practice it so that you can prepare yourself for practice 2, which is the testing of the vocabulary. Okay. So what I would like you guys to do today is practice number 2 and practice 3. Practice 3 is a video. And as with all of my videos, you have to put this password in here. Unfortunately, not with all of them, but with this video in particular, you have to click the link and then put this password in, which is capital T, capital H, capital E, lowercase edu. It's not my video, it's a public video, but this is how they keep it protected for only people who work in the education system. So that's the password you have to use. And it'll teach you a little bit about why Earth's air is important. So again, there's nothing you really have to do for this except watch the video and then write about your reflection. What did you learn, right? What ideas did it bring up? What important thing would you like to learn more about if there's anything, right? Or what fascinated you? What surprised you? Anything, whatever reflection you have after watching the video is what I'd like you to share. It's about 20 minutes, a little bit shorter than that, I think, actually. And that's what I would like you guys to do for today, right? So whenever you're ready, after learning about your vocabulary, take your practice 2 assessment and see if you can match those words together, and watch the video on air pollution. If you would like to, and you want to learn a little bit more about pollution, practice number 4 is also included. That is not something that you have to do today. What I would like you to do are practices 2 and 3. Practice 4 is there for you if you would like to learn more about how we define pollution, and what particulate matter is, all right? And actually let's see, this is perfect. We actually have enough time. We can actually learn about that today. We're gonna read it ourselves. Never mind. We're gonna read about particulate matter right now. We have time. Why not? We have so much time. Oh my goodness. I was trying to give you guys the 20 minutes, but you guys have more than 20 minutes to watch the video. You have plenty of time. Okay, so again, this is about pollution and particulate matter. Particulate matter is about the things that are in our air. So we're going to read a little bit more about these gases and what kind of effects they have on the world. So we're going to start with nitrogen dioxide. Who would like to start us reading? What is NO2 and how does it get in the air?
Okay, should I start?
Yeah, go ahead. What is NO2 and how does it get in the air?
Oh, practice 4, right?
Yeah,
Yeah, practice 4.
nitrogen dioxide, NO2, is one of the group of highly reactive gases known as oxides of nitrogen or nitrogen oxides,
Uh-huh.
NOx. Other nitrogen oxides include nitrous acid and nitric acid.
Nitric acid.
Nitric acid,
Mhm.
NO2, is used as the indicator for the larger group of nitrogen oxide. NO2 primarily gets in the air from the burning of fuel. NO2 form from emission from cars, trucks, and buses, power plants, and off-road equipment.
Okay, very good. So NO2, one thing that's not mentioned here too is NO2 is in any of those cars that are souped up. And if anybody has watched those Fast and the Furious movies, NO2 is the gas that actually makes your souped up car go even faster. Okay. All right. The health effects of NO2. Can someone read that for us?
Breathing here with a high concentration of NO2 can irritate airways in the human respiratory system. Relatively brief exposures to the gas can aggravate respiratory disease, particularly asthma, leading to respiratory symptoms such as coughing, wheezing, difficulty breathing. Hospital admission, and visit to emergency room. Longer exposure to elevate concentration of NO2 may contribute to the development of asthma and potentially increase
susceptibility
to respiratory infection. People with asthma, as well as children and the elders, are generally at greater risk for the health effects of NO2.
Okay, good. So NO2, right, this biggest challenge, right, because it's present in our air, can actually cause asthma symptoms, right? So reducing NO2 is actually really beneficial, as it will make sure we protect children and elderly who are at the greatest risk of developing symptoms from NO2, right? So it's not a big presence in our atmosphere right now, but again, as people enjoy the faster going cars and all of these other vehicles that use this gas, that's when it will end up more in our systems. Okay. What about the environmental effects and what is being done? Who can read that for us?
What about the environment effects?
Yeah, who's next?
NO2 and other NOx interacts with water, oxygen, and other chemicals in the atmosphere to form acid rain. Acid rain on sensitive
ecosystems
such as lakes and forests. The nitrates particles that result from NOx make the air hazy and difficult.
Makes the air hazy.
Makes the air what?
It makes the air hazy, like you can't really see it.
It makes the air hazy and difficult to see through. This affects the many nation parks that we visit for the view. NOx in the atmosphere contributes to the nutrients pollution in coastal waters.
Okay, great. So when we have NO2 in the air, it causes acid rain, right? So acid rain isn't rain that like feels like acid, but it is rain that is so acidic as it can be harmful, right? Water is supposed to be relatively in the middle, neutral, not a base, not an acid. It is actually a little bit more basic than it is acidic. But with all of this pollution, it creates what is called acid rain. So rain that is, so water that is a little bit more acidic and it comes down. And so when it's more acidic, it's harmful to lakes and forests and those places where it falls, right? And also when you see it in the air, when it is in the air is hazy and more difficult to see through, right? So think of like a really hot day. When you have a really hot day and you look off into the distance, everything is hazy, right? Air pollution also causes things to become hazy and things not really very visible.
You mean like fog? Sorry to cut you.
Sort of like, yeah, sort of a little bit like fog, right? But also just like the idea that things just don't seem the right or correct in the way that you're viewing it, right? But also NOx can get into our coastal waters. So anything that lives in the ocean or in rivers can become polluted with the effects of nitrogen, making them harmful to consume, right? So the fish or whatever.
That's like sometimes when you see, they'll show you that the fishes on the lakes or the rivers, there's so much of them that just float out, that's dead.
Right, correct, because the water is polluted. Yep, absolutely. Yeah. Okay. So what's being done to reduce the NO2 pollution? Well, EPA's national and regional rules to reduce the emissions of NO2 and NOx will help state and local governments meet the national ambient air quality standards. Whew. So NAAQS, right, is what that is. It's the National Ambient Air Quality Standard. This is something that the government or a government agency has tried to enact to make sure that there is a reduction in the emissions of NO2. So the EPA identifies areas where the air quality does not meet the national NO2 standards. For these areas, state and local governments develop plans to reduce the amount of NO2 in the air. Enforcement of these standards has unfortunately been highly variable, right? So what that means is that some jurisdictions, some areas, they enforce it more than in other areas when it comes to NO2 emissions, right? So why might one government area or agency decide to enforce those rules and why would another one not want to enforce it?
Could you repeat the question, Mr. G?
So why is it that it varies, right? So it says enforcement of these standards has been highly variable, meaning that only in some places do they actually enforce the rules to reduce the amount of NO2. Why would one place say it's okay to have high NO2 and another place say it's not okay? Why would they have that difference?
Because maybe the population.
Mm-hmm. Like the population benefits from having the high NO2?
Like places like countries where it's underdeveloped, they don't really enforce this thing.
Mm-hmm. Well, we're talking about in this country.
From it, Mr. G.
Oh, okay. Oh, I don't know much about America.
Yeah, so it's saying it's different in different parts of the US, right? Because the EPA is a US agency.
Okay.
So why would some places in the US enforce it and other places not?
I don't know about that. I don't know.
I don't have a definite answer. I just wanted to know what you guys think about that.
Maybe because some places have more water than some.
Okay. All right, right. So some places might be more concerned about their pollution than other places. Okay, because of that. Yeah, that makes sense. Okay. Yeah, it could be. I don't know. I don't have an answer for that. I just found it interesting. I wanted to see what you guys thought.
Okay. Maybe because they don't believe in believe that is harmful. Maybe.
Okay, that's true. That could be it too, right? If they don't believe it, then they're not going to enforce it. Right? That's really true. Okay. What is PM and how does it get into the air? So what is PM?
Okay, should I read?
Sure, go ahead.
PM stands for particulate matter, also called particle pollution. The term for a mixture of solid particles and liquid droplets found in the air. Some particles, such as dust, dirt, salt, or smoke, are large or dark enough to be seen with the naked eyes. Others are so small they can only be detected using an microscope.
An electron microscope. Yeah, good.
Yeah. Mm.
All right. So PM, or particulate matter, right, is just things that they're so small we can't see them, right? We can see a lot of the harmful things in the air generally, but there are some things we just can't see. And this is what particulate matter is. So particulate matter, just to kind of summarize these next couple paragraphs, right? Particulate matter is the stuff that's so small that it has to be detected by a scientific agency. But those scientific agencies are important in letting us know if our air quality is good or bad. And it's an important thing when we're thinking about, especially like being outside in the spring for people who have allergies. If you watch the news during the spring, or maybe you guys remember, and sometimes also in the fall, when the weather is changing, when different things are in season and blooming, they make these announcements every day as to the air quality and like the pollen count, right? So people who do suffer from allergies know whether or not they should be outside or not, or whether they need to take extra medicine or something like that, right? Because there's going to be so many things in the air that is going to affect their ability to breathe, right? So they measure these things and they let us know. Usually on the news, they'll be like, oh, the pollen count is very high, or it's not very high today, or whatever the situation is. These are the things that they have to let people know because of how sensitive some people might be to what might be found in the air. All right, so they measure the particulate matter.
Having plants around your house too, Mr. G, you can be allergic to it and you don't even know.
Right, exactly, absolutely, yeah. So these fine particles can also create haze, right? And they also can reduce your ability to see, but that's what particulate matter is, and that's what pollution is, right? So pollution, to summarize this idea and what we kind of tried to read in these last 2 pages, right? So pollution is things that we can see, right? But it's also things that we cannot see. And some of the things that we can't see can be just as harmful as the things that we can see, okay? So that's why it's kind of important to have these scientists around to measure these things for us, because of the things that we can't see. Those things that we can't see can just be as harmful. We have to make sure that we're aware of that as well. All right. Okay, so again, you guys should be good on your practices for today. Practice 4 is already, we've just read it. So essentially just completed it. So you don't even have to worry about practice 4. It was always just an extra assignment anyway, but now we've done it. So make sure you just go through and prepare yourselves for practices 2 and 3. And I will see you guys next Friday. We do have one more Friday before Thanksgiving, right? So we will make sure that we get to work next Friday and learn a little bit more about how our indigenous populations, the people who are native to this country and also to other countries, and how they deal with the idea of climate change. Okay?
Okay.
Mr. G, may I ask, do you have a midterm like the other classes?
For science, no.
Thank you.
No.
Mr. G, last week I have completed.
All right. So again, if you do the week 7 assignment on ocean acidification, you can answer the questions directly on the site. You don't have to transfer it back to Schoology.
Okay, I'll do so. Okay, thank you so much.
No problem.
Yeah,
all right, everybody else, enjoy the rest of your Friday the 13th. I will see you all next week.
Thank you, you too. And everyone, have a great weekend.
Yes, stay safe.
Yeah, thank you. Bye. Yeah, bye-bye.
Oh wait, Miriam, I had a question. Don't go anywhere.